Welcome to our STEAM project number 8, based on the BBC Microbit, the GeekPy Microcar and Microsoft MakeCode. In this lesson, we are going to combine much of what we have seen so far into one project. This course is at the introductory level. We actually assume that you don't have any prior knowledge of programming, sensors or actuators. We call this level the Scout level. My name is Peter. I am the founder of Educomondo and a certified STEAM instructor and course designer. In this project, we have one main objective, and that is to combine many of the projects that we have already seen into one big project. The aim is to keep a cool head on all of the programming that will happen in the Microsoft MakeCode environment. To do that, it's handy to make a list of all the actions that we want to take place. First, the ultrasonic sensor, for which we will need the extension Sonar. The RGB lights, for which we will need the extension NeoPixel, and the OLED display, for which we will need the extension OLED 12864_I2C. And as we want also to create some alerts, we also need the function music. The remainder will be reading and writing from digital and analog pins. So let's go to the Microsoft MakeCode and start our programming. And here we are in our live session. And the first thing we need to do is to create a new project. Give the project a meaningful name, for instance, Robot Car Total. Hit the create button and we are in business. The first step that I always do when working with robots and with the microbit is to ensure that there is no pin conflict throughout the program. And we do that by disabling the onboard LEDs of the microbit. And I drag this LED enable false into the on start block. The next thing that we want to do is to install the extensions that we will need. And we will need the extension Sonar, NeoPixel and OLED. So extensions, search for Sonar, and it is the first one that appears in the list. And once that has been installed, we can go to the next one, which is the NeoPixel. Install it, and we are ready to go for the last one, which is the OLED 12864 I2C, and that has also been added. The next step that I would like to take is to create the functions that will control the motor movements. And I'm going to create the functions that we already have created in previous projects, so forward, backward, left, right, and stop. This time I am going to use the analog right functions because that will give me just a little bit more the opportunity to create fluent turns with the microcar. Under Advanced, you see functions. I make my first function Let's call it forward. And forward is going to be a series of analog writes to the pins that control the motors. The motors are controlled by 4 pins, so I'm going to copy paste this another 3 times so that in total I have my 4 pins. And those pins, I hope you still remember, are pins 13, pins 14, pin 15 and pin 16. For my forward movement, I have to power up pin 14 and pin 16, which means that 13 and 14 can be set to 0. I can simply copy paste the whole function, and I will call this one backward. And for that I need to set pin 13 to 1023, pin 14 to 0, pin 15 to 1023, and pin 16 to 0. Now let's create the right and left movement. So I can use this one as right. And to go to the right, I have to initiate pin 14 to get full power. Pin 15 I set to 0. And the analog right to pin 16 I can set to, for instance, half of the power. So let's put it to 512. That's for the right turn. I can copy paste the whole function and rename it left. And for left, I have to change pin 14 to 512 and pin 16 to 1023. And then there is only one left, which is the full stop. So call this stop. And of course, this will be accomplished by setting all the pins to 0. I can move all of these functions away so that they are not going to interfere with the rest of my programming canvas. That's better. Okay, we can now start by programming the ultrasonic sound sensor. The extension sonar that we just downloaded is creating a variable defined by the distance that the trigger and the echo pin create, either in centimeters or in inches. So I have to create a variable, and I'm going to call it distance. And now I can create the variable distance by changing the 0 to the number, the variable that the sonar extension is going to create. But it can only create this variable when we are using the correct pins. And the trigger pin is located to pin 12, echo pin is pin 9, and the unit we are using is centimeters. Of course, if you live in a part of the world that uses inches, you can always use inches in this project. We have the distance. Now we can build a logic around it. And the logic will be really driving the core of our program, because what we want is that the moment the robot car enters the zone between 0 and 15 centimeters of a particular object or an obstacle, then we want the car to stop for a short while and turn away from that obstacle and start driving again. So we need to do a number of activities based on a number of conditions. And those conditions can be found in the logic block, because as I said, it has to be between 0 and 15 centimeters. So there will be two conditions that need to be met. So I'm using the Boolean function. And what are those two conditions? Well, first, that the distance has to be larger than 0 and that the distance has to be smaller than 15 centimeters. So I go to my logic again, and I'm going to do and create those two comparisons. This is comparison 2. My variable is distance, and I want that distance to be larger than or equal to 0. And I want my variable distance also to be smaller than 15. The first thing that I want to initiate what will happen if the sensor measures a distance that is smaller than 15, the first thing is to stop the microcar. And I do that by calling the function, call the function stop. Then I'm going to wait for a short while by introducing a pause of, let's say, half a second. And then I want the car to move to the left or to the right. So we can go back to my functions because I want to call the left function. The car needs to drive for a certain period of time towards the left in order to avoid the obstacle completely. So I need to introduce another pause, and it might well be that we have to use quite a long pause here, a long delay of, let's say, 1 second. If, of course, the condition is not met, which means that the car and the sensor are outside of the 15 centimeter border or boundary, then I can call the function forward, because in that case the microcar can happily drive forward. That is controlling my motors and the ultrasonic sensor. The next thing that I would like to do is to bring some color in our robot car by initiating the RGB LEDs. So first of all, I have to create a new forever block, and I'm going to explore what are the functions in my NeoPixel extension. And the first thing that I need to do is to set up the strip. It's called the variable strip. It's immediately a variable that is being created. So that strip I have to initiate, and the initiation is done in the on start block. I have to change the pin number because it's not at pin 0, but it is at pin 6. And I don't have 24 LEDs, I only have 4 LEDs. And yes, they are in the RGB format. Now I need to also tell the system that I want all of the colors displayed, and I do that by adding the show rainbow function underneath the on start block that we already put in place for the strip, the RGB strip. That's for the on start. Now what do we want it to loop forever and ever? Well, we want to rotate the pixels so that each of the RGBs is going to give us a different color. So I am going to rotate the pixels by 1. Now note that if I hover over this particular block, that it tells me, beware, if you are using this block to rotate your LEDs, you also need to call the show function. So I'm going to do that, and I find the show function over here. Also, in order for our human eye to observe nicely the changes in the colors, I am going to introduce a short pause. 100 milliseconds is sufficient to really enjoy the wonders of these ever-changing colors. The next thing that I want to do is the OLED display. So let's have a look what we have here. The first thing we need to do is to initiate it, and I have to go back to my on start, and it's here with address 60, and that's just fine. That will work. Let's measure the temperature from the microbit sensor and display this on the OLED by creating a new forever block. And here is my new block. And I want to show a couple of things. The first thing is I want to tell the people, the person who is watching what appears on the OLED, I want them to tell that what you are looking at is the temperature. So the first thing is to show a string, which is another word for text, and I want the text to be temperature. And it's going to be in the upper corner to the left, and that is position 0, 0. The next step on the next line, I want to show the temperature reading, and I do that by showing a number. Not at position 0 for the y-axis, but at position 1. And I'm going to include my variable, and the variable is something that I find here under input, so temperature, and I change the 12 by temperature. So this is going to display the temperature in degrees Celsius. But of course, the people who are watching what's happening on the display don't know that it is in Celsius. So to get really absolute clarity, it's always good to add another string telling them that it is Celsius, and that the number they see makes, of course, then sense. So another string, position 0 and 1 we already had, so this is going to be position 2, and I'm going to replace hello with Celsius. And that's it. We don't need to include any pauses or anything like that for this particular reading. The last part is to add some music. Let's say that we want to sound an alert the moment that the robot car gets into the range between 0 and 15 centimeters, so that people are alerted that the car will be turning. So I will create a new forever block, and I have to recreate the if and the conditions. So it's going to be a logic block, logic, and just a simple one where I'm going to once again compare two values or two statements in a Boolean comparison, and the logic, these are the comparisons. Just make sure that it's the right one, yes. And here my variable distance has to be larger than 0, and my variable distance has to be smaller than 15. And then I want to play some music, and I'm going to use a tone, selecting play, tone for a particular sequence in beats, and if I click on middle C, I get a nice keyboard, and as I hover over the different keys, I can select the tone that I want. And for this particular project, I want middle A, because that is a tone that is sufficiently high-pitched to catch the attention of the people around the car. And we leave the number of beats to 1. Until it is done, until the if statement is done, and that is for me, I think, almost everything. So that should do it. If all is well, we should now have a self-driving, obstacle-avoiding, colorful robot car that shows us the temperature and alerts us when it is turning. So I'm going to connect my BBC, download the program, and once that is done, disconnect from the USB cable, switch on the robot car and see what's happening. If all is well, you will see that the car is driving happily until it encounters an obstacle, it turns away, and then proceeds its route. That's it. Here are some ideas of additional programming that you can do with this project. You can change the RGB LED behaviors to explore more of the functions in the NeoPixel extension. For instance, you can change the colors of the RGB LEDs to only show red, green, or blue. You can also change the melody or the speed of the sound. This project is a great opportunity to explore more of the functions and the extensions that are available in the MakeCode blocks. So let your class experiment with the things that they encounter. That's it for project number 8, in which we were able to bring together much of the previous projects into one larger project. In our next project, number 9, we are going to add some additional sensors and actuators, specifically a servo motor to the robot car. Bye bye for now.